The Inuit are famous for their ability to survive extreme conditions after having lived in the Arctic for millennia. However, the leaders of these hardy group of people are warning about one problem that humanity is facing. The Earth is shifting. What is causing the Earth to shift, and what are the effects? And why should we pay attention to those Inuit elders? In this video, we dive into Inuit elders' terrifying warning to NASA and the world that the Earth has shifted. The story of the Inuit is basically the story of the Arctic because these people have inhabited the region for thousands of years. The Inuit were a nomadic people who spent their time hunting and fishing for centuries, but they have now become sedentary. More than 125,000 Inuit from approximately 40 different ethnic groups live in a vast area that includes parts of Alaska, Canada, Greenland, and Russia. One remarkable thing is that despite being separated by vast distances, the Inuit have remained remarkably homogeneous. The Inuit have learned to live with what their harsh environment provides them with: polar animals, ice, stones, and so on. Their main source of nutrition is seal fat and meat, which is high in iron and vitamin A and helps them survive the cold. Above all, they have adapted culturally. Their clothing, snowshoes, dog sleds, kayaks, hunting strategies, and so on are all custom-made for the Arctic. The Inuit civilization is still based on hunting and fishing. In exchange, they treat nature with great and uncommon reverence. Around 5,000 years ago, several groups of people settled on each side of the Bering Strait, which was free of ice at the time. The region drew hunters from all over the world because it provided a diverse range of fauna both on land and at sea. The first traces of the Inuits' ancestors were discovered in this region. After 1,000 years, the American continent's ice caps melted, and hunter communities along the Bering Strait migrated southwards into America and along the Arctic coast as far as Greenland. Prehistorians studying vestiges and fossils from this era use the term Eskimo to describe hunter peoples that adapted to the coastal resources of the Arctic. This period and culture are divided into two major prehistoric periods and cultures: Paleo-Eskimo and Neo-Eskimo. The latter branch spread across the entire Arctic, and they are the ancestors of today's Inuit. The Inuit are very much in tune with nature because until about 30 years ago, the Inuit relied entirely on hunting for not only food, but also materials to make tools, build shelters, and make clothes. Their way of life allowed them to derive a subsistence income from their fragile natural environment without destabilizing it. The Inuit hunted marine mammals like seals, walruses, and cetaceans in the winter and moved inland from the coast in the summer to hunt caribou, fish in rivers and lakes, snare birds and take their eggs, and gather berries and herbs. However, as remote as their habitation may be, the Inuit are finding themselves at the center of a geopolitical climate change debate that they didn't cause. What is worse is that they are now witnessing dramatic shifts in the natural environment around them. And what is even worse is that the changes have dire consequences for the rest of the world. The Inuit elders are warning that the land and weather are becoming unpredictable and dangerous. Warmer, more unpredictable winds are blowing from unexpected directions. Severe flooding threatens to wash towns away, and native animals, the food supply, aren't acting like they used to, their bodies becoming less capable in the changing climate. And yet even stranger, the sun now appears to set many kilometers away from its usual position on the horizon, and the stars are no longer where they should be. The Earth is shifting on its axis, altering the appearance of the sun and stars. But the problem is, nobody has ever listened to these people over the years. Every time there is a discussion about global warming or Arctic warming, scientists go up there and do their work. Policymakers rely on their findings, but nobody ever fully comprehends these people. The elders describe in great detail how seals, a staple in their diet, are behaving strangely as a result of the thinning ice, how warmer winds are changing the snow and ice banks, making overland navigation difficult, and how major floods are affecting communities. The planet does tilt, and the tilting comes with serious consequences. Actually, the rotation of the Earth causes daily changes in light and temperature, while the tilt of the Earth causes seasonal changes. The gravitational forces of the Sun, Moon, and large planets in the solar system, primarily Jupiter and Saturn, pull the Earth as it orbits the Sun, the gravitational pull of other members of our solar system gradually changes Earth's spin, tilt, and orbit over long periods of time. These gravitational forces gradually shift Earth's orbit between more circular and elliptical shapes over 100,000 to 400,000 years. The tilt of the Earth shifts over 19,000 to 24,000 years or spins. In addition, the amount of which the Earth's axis is tilted towards or away from the Sun changes over approximately a 41,000-year cycle. Over long periods of time, small changes in the Earth's spin, tilt, and orbit can change the amount of sunlight received and thus absorbed and re-radiated by different parts of the Earth. These small changes in the Earth's position in relation to the Sun can change the amount of solar radiation, also known as insolation, received by different parts of the Earth over tens to hundreds of thousands of years. Changes in insolation over long periods of time, in turn, can alter regional climates, as well as the length and intensity of the seasons. The Earth's spin, tilt, and orbit are still changing today, but they do not explain the current rate of climate change, as some may try to claim. Changes in insolation cause ice age cycles in which ice sheets expand during glacial periods and contract during interglacial periods. Milutin Milankovic, a Serbian scientist, predicted these ice age patterns known as Milankovic cycles. Milankovic predicted that glacial periods occur during low summer insolation at high altitudes in the northern hemisphere, allowing ice sheets to remain year after year without melting. Following that, scientists discovered a wealth of evidence of Milankovic cycles preserved in the geologic record, particularly in layers of sediment and fossils in ocean basins that preserve chemical changes in the ocean and atmosphere during glacial and interglacial periods. Although a major cause of change in the past, the Earth's spin, tilt, and orbit change so slowly that it's no longer a cause of global warming and climate change today. Changes in the Earth's spin, tilt, and orbit have all had an impact on the Earth system on various scales in the past. Among these methods are increasing or decreasing the amount of sunlight absorbed by different areas of the Earth's surface. This can have an impact on Earth's temperature. Temperature changes, which can affect the distribution of snow and ice cover. Increased snow and ice cover, particularly at high latitudes, can increase sunlight reflection, reducing the amount of light absorbed by the Earth's surface. Changes in the Earth's system caused by snow and ice covers, such as the carbon cycle and the amount of carbon, including the greenhouse gas carbon dioxide, transferred between the atmosphere, biosphere, and ocean. However, scientists have for a while been warning about something else that is shifting the Earth's axis, just as the Inuit elders have warned: melting glaciers. The Earth's axis shifted dramatically in the 1990s. The Earth's axis moves by a few centimeters every year, which is not unusual. However, in the 1990s, the direction of polar drift abruptly shifted and the rate of drift accelerated. The cause of this abrupt change was previously unknown, but a team of scientists in Beijing recently published a paper demonstrating that glacier melt caused by global warming was the primary driver of the change in the direction of the axial shift. Prior to human-caused forces, ocean currents and the movement of molten rock deep beneath the Earth's surface were the primary drivers of polar drift. The researchers reanalyzed existing data to see what role terrestrial water storage, how water is distributed above the Earth's surface, in oceans and in groundwater, played in the shift. They determined that glacier melt and the resulting change in mass distribution were the primary drivers of the directional change. The majority of the world's glaciers are above ground, and when they melt, the water they contain flows into bodies of water. Polar shift due to weight change results from shifting water storage away from above-ground glaciers in one area of the Earth's surface to another. The direction of the planet's polar drift abruptly shifted from south to east in 1995. Using gravitational data from NASA's Twin Gravity Recovery and Climate Experiment (GRACE) satellites, scientists can now link polar drift to glacier loss. However, because the satellites had not yet been launched in the 1990s, researchers were forced to piece together the reasons for the abrupt directional shift in the absence of these detailed gravitational records. Other human activity aside from greenhouse gas emissions that cause glaciers to melt is to blame for changes in the Earth's hydrosphere. The team also discovered that groundwater pumping was and still is a factor in polar drift. Pumping groundwater for drinking water, irrigation, and manufacturing has been common since the 1960s. Every day, the United States alone consumes 82.3 billion gallons of groundwater. Water extracted from the ground ends up in the atmosphere as it evaporates from irrigated crops, or in the ocean as runoff from irrigation systems into rivers, redistributing mass around the world and changing the planet's rotation. The Earth's mass is constantly redistributed as glaciers recede at unprecedented rates. The findings of the team indicate that the hydrosphere will continue to cause the Earth's axis to shift in the coming years. The enormous mass of the Earth has been shifting more than ever recorded, though it is imperceptible to humans without the use of specialized instruments. Polar drift has increased by about 4 centimeters per year since 2005. While the change is nothing that a regular person would notice in their day-to-day life, the consequences are dire and are a stark reminder of the magnitude of human impact on the planet. And these changes in the Arctic are having serious effects on the Inuit people. For example, the elders can recollect when immense icebergs once floated along the Northwest Passage, the popular Arctic waterway linking the Atlantic and Pacific Oceans. The whole aspect of the traditional life of these indigenous people is changing due to the changes in the Northwest Passage. The Northwest Passage, which spans approximately 1,450 kilometers, earned a reputation among outsiders as intractable and haunted due to the capricious interplay of its ice, snow, and sea over the past 2 centuries. The marine ice pack killed many who attempted to chart the Northwest Passage, most notably the doomed Franklin expedition, making it an impediment to commerce and colonization. However, the passage is becoming busier as warmer temperatures reduce sea ice, allowing more ships to pass through. The Arctic as a whole is an emerging commercial center and a geopolitical stronghold that is already being contested by governments. A diverse range of corporate, federal, and military interests mobilizing to capitalize on the Arctic's increasing accessibility to vessel traffic, which is being heralded by the projected loss of ice cover. The Arctic is warming at nearly twice the rate of the rest of the world on average and up to 3 times faster in some communities, causing waterways such as the Northwest Passage to lose ice each year. According to a study, average Arctic temperatures are higher than they have been for tens of thousands of years. This trend was most recently exemplified by a record Arctic temperature of 38 degrees Celsius or 100.4 degrees Fahrenheit in Siberia amid devastating wildfires. When climate change worsens, it is first noticeable in the Arctic, whether it is the Arctic waters or the land. But Inuit experienced this firsthand before anyone else in the world, despite not contributing much to the pollution in the first place. And this difference is profound for the Inuit. The difference between a 1.5 degrees Celsius and a 2 degrees Celsius world is a summer without sea ice every 100 years rather than at least once every 10 years. Such rapid changes have far-reaching consequences for Inuit lives and livelihoods. Permafrost thawing, a layer of soil that remains frozen all years, causing damage to people's homes, potentially affecting millions of Arctic residents. Many Inuit communities have already been forced to relocate from their traditional lands due to coastal erosion and extreme weather events. Many Inuit communities rely on subsistence, hunting, and fishing for food and income, but rising temperatures are already disrupting Arctic food webs. The disappearance of thick sea ice in the Alaskan city of Kotzebue has disrupted the marine ecosystem, threatening the community's traditional seal hunts and subsistence diet. Some studies predict that within a few decades there will be almost no summer sea ice covering the Arctic Ocean. Though some inland communities rely more on land animals like caribou, most Inuit traditions, livelihoods, and diets are inextricably linked to marine mammals. Narwhal, beluga whales, bowhead whales, ringed seals, and walrus are not only a source of food, clothing, and tools for Inuit, but they're also an important part of their ritual life. Traditional activities that were previously coordinated with migratory opportunities become out of sync. There is a natural rhythm and pattern to not only fish, wildlife, and bird movements during the winter and summer seasons, but also a slew of traditional gatherings and harvesting activities. And increased shipping activity will put even more strain on these vulnerable ecosystems and the communities that rely on them as the Northwest Passage and other Arctic waterways become more accessible to vessels. And vessels pose a variety of potential threats to Arctic marine mammals, including ship strikes and noise pollution. Arctic marine mammals are sentinel species, which means they are likely to be the first animals to experience measurable effects of environmental stresses such as climate change. As a result, they serve as a kind of forerunner of what is to come for a region's overall biodiversity. An increase in shipping also increases the risk of major oil spills or other industrial accidents. Unfortunately, this is not hypothetical for Arctic communities. The 1989 Exxon Valdez disaster still looms large for indigenous communities affected by it. Simon Natak, an Inuit, paid a high price for the melting permafrost in the Arctic, his legs. Natak, a traditional Inuit hunter from a remote part of northern Quebec, came across a patch of ice thinned by climate change near his home. His snowmobile sunk into the murky waters. According to his neighbor, Inuit environmental and human rights advocate, author, and Nobel Peace Prize nominee Silawatt Cloutier, searchers discovered him 2 days later in a snowdrift he had dug into for insulation. When they did, they had to amputate his frozen legs. What was so shocking about his accident was that Natak's generations of experience reading snow and ice, which began as a child, weren't enough to keep him safe. Stories about hunters breaking through ice were uncommon when Wat Cloutier was growing up, but she claims that after an attack fell in 1990, similar stories and other troubling changes began to arrive from every corner of the circumpolar north. Such occurrences are now commonplace nearly 30 years later, and Natak was among the lucky ones. In a recent year, 5 people died after falling through the ice in Alaska. Patricia Cochran, executive director of the Alaska Native Science Commission and an Inupiat Inuit, says she is witnessing the same phenomenon in Alaska. Everyone knows someone who fell through the ice and never came back. The Alaska Native Tribal Health Consortium discovered that the number of accidents increased each year between 1990 and 2010, with the majority of victims being Alaska Natives. Melting ice has made snowmobile travel unsafe in many areas. Many indigenous peoples in remote villages are taking risks in order to provide for their families. Some Alaskan hunters have returned to using traditional dog sleds. The dogs are reportedly better at anticipating dangers and will not attempt to cross thin ice. However, even dogs will not be sufficient to ensure safe travel for much longer. A scientific expedition discovered that permafrost in the Canadian Arctic is thawing 70 years earlier than expected. And for people not living in the Arctic, this is not some distant issue. What happens in the Arctic doesn't stay there. The rising sea level caused by disintegrating polar regions, particularly Greenland's melting ice sheet, is expected to flood parts of Florida and major US cities. But it doesn't stop there. Recent research has shown that Arctic warming affects the jet stream, resulting in extreme weather across much of the northern hemisphere. Wildfires, heat waves, drought in some areas, and heavy storms and flooding in others. As the Arctic continues to warm, these extremes are expected to worsen. Scientists warn that if the Arctic is lost, the world will lose the wisdom that the Inuit can teach about living on the planet in a sustainable way. And while the Arctic people are trying to deal with the floods related to climate change, the environmental crisis is having another effect, flooding the area with light. The Arctic Ocean is the world's smallest and shallowest ocean, covering just over 14 million square kilometers. It also happens to be the coldest. A vast raft of sea ice floats near its center, expanding during the long, cold, dark winter and contracting during the summer as the sun rises higher in the sky. Every year, usually in September, the sea ice cover reaches its minimum extent. The total area in 2020 was 3.74 million square kilometers, the second smallest in 42 years and roughly half of what it was in 1980. As the climate warms, the Arctic holds less and less ice each year, and the warmer water is causing some species to migrate further north into higher latitudes. Because of the thinner ice, more people are traveling through the Arctic on cruise ships, cargo ships, and research vessels. Although ice and snow can almost completely obscure the water beneath it, climate change is allowing more light to enter. In the Arctic, light is extremely important. The algae that make up the Arctic Ocean's food web convert sunlight into sugar and fat, which feeds fish and eventually whales, polar bears, and humans. Now, the sun remains below the horizon for 24 hours at high latitudes in the Arctic during the depths of winter. This is known as the polar night, and the year at the North Pole is simply one day lasting 6 months followed by one equally long night. In the autumn of 2006, before the fjord froze, researchers studying the effects of ice loss deployed moored observatories in the Arctic fjord. The moorings had been in place for nearly 6 months when sampling began, collecting data throughout the long and bitter polar night. What they discovered altered everything. Scientists assumed at the time that the polar night was completely uninteresting, a period when life ceases to exist and the ecosystem enters a dark and frigid hibernation mode. These measurements were not expected to yield much, so researchers were surprised when the data revealed that life does not pause at all. Arctic zooplankton, tiny microscopic animals that eat algae, engage in what is known as diel vertical migration beneath the ice and during the polar night. Migrating to depth during the day to hide from potential predators in the dark and surfacing at night to feed, sea creatures do this in all of the world's oceans. Because organisms use light as a cue to do this, they shouldn't be able to do so during the polar night. We now know that the polar night is a flurry of ecological activity. In the gloom, the normal rhythms of daily life continue. Clams open and close cyclically, seabirds hunt in near complete darkness, ghost shrimps and sea snails congregate in kelp forests to reproduce, and deep-water species like the helmet jellyfish surface when it's dark enough to avoid predators. The moon, stars, and aurora borealis are most likely important cues for most organisms active during this period, especially in parts of the Arctic that are not covered by sea ice. However, as the Arctic climate warms and human activity in the region increases, these natural light sources will become invisible in many places, crowded out by much stronger artificial light. Almost a quarter of all landmasses are exposed to scattered artificial light at night due to atmospheric reflection. There are few truly dark places left, and light from cities, coastlines, roads, and ships can be seen from space. Light pollution can be seen even in sparsely populated areas of the Arctic. As the sea ice recedes, shipping routes, oil and gas exploration, and fisheries expand into the region, bringing artificial light into the otherwise inky black polar night. No organisms have had the opportunity to adapt properly to these changes because evolution operates on a much longer timescale. Meanwhile, the Earth, Moon, and Sun have been providing reliable cues to Arctic animals for millennia. Many biological events such as migration, foraging, and breeding are highly tuned to their gentle predictability. The onboard lights of a research vessel were found to affect fish and zooplankton at least 200 meters down in a recent study conducted in the high Arctic archipelago of Svalbard between mainland Norway and the North Pole. The creatures swirling beneath the surface reacted dramatically to the sudden intrusion of light, with some swimming towards the beam and others swimming violently away. The impact of artificial light from ships newly navigating the ice-free Arctic on polar night ecosystems that have known darkness for longer than modern humans is difficult to predict. As sea ice recedes from the coasts of Greenland, Norway, North America, and Russia, periods of open water lengthen and more light reaches the sea floor. Coastal ecosystems that have been hidden under the ice for 200,000 years are suddenly emerging. This could be great news for marine plants like kelp, which thrive in cold water with enough light and nutrients.